What's going on, everybody, and welcome to part 2 of our playing with Google Takeout data video mini-series thing. So in this video, what we're going to be doing is now building some bar graphs, basically, from the top 10 we're probably going to go with. Most common words with a sliding one-year window, and later we can try different windows, or you guys can just do it on your own time. But for now, we'll do a one-year window. So with that, let's go ahead and get started. So you should at this point have mylife.database, and that should be populated with the primary key, Unix, and then all of the unique words. So what I'm going to do now is I'm just going to copy search database, and I'm just going to rename this to be I don't know, images. And then open in Sublime. I'm going to close that old one because that doesn't really matter anymore. So now, and in fact, I kind of want to keep the original just so I don't have to retype some stuff. So we still want to connect to mylife.database. We don't need the search activity directory anymore. We don't need to parse dates, and that should be good. So the next thing I'm going to do is we need a directory that we're just going to dump all these images into. So I'm just going to make a new directory real quick. And I'm going to call this images. Let's do word images, and we're going to start with 1 year window, 1 day slide. It's kind of a long directory, but we'll go with it. That's fine. So, well, I probably we'll work that in a minute. So now what we're going to do is we're just going to specify some starting constants. So a day we always know is 86,400, so 86,400 seconds. And then a year would be equal to 365 day. And then for our slide, we're going to say that is equal to 1 day. Okay, so with that, what we're going to do is just start generating our word graph. So we're going to say define words graph. Now what we want to do is we're going to save everything into here. So I'm going to copy that, come into here, and I'm going to say savedir equals that. So that's where we're going to stuff all the images. Now what we want to do is, first of all, we need a starting and an ending time. So we should be able to do a query, I think. So something like, I don't know what it is. Let's look it up real quick. SQLite max column. SQLite max column. Okay, hold on. Find SQLite find max. We could also try min. I just want to see the expression, man. Select max from, okay. So the first thing that we could do is we could, all we want to do is find the minimum time and maximum time. So let's do words graph, and then we're going to say, well, we're just going to do a c.execute, I guess select max Unix. I feel like I have a hair or something over here. Select max Unix from words, and then let me just print. I'm just gonna say d equals c.fetch all, and then we'll print d. Okay, so that's our max time. So then we'll just say max time equals d. Well, we can just say this. We can't call two fetch alls, but we should be able to just do that, and then 0 0, right? 0 0, and then we should. Oh, we're doing the stupid tab thing, huh? Why don't you let me do this? There we go. Thank you, sir. Thank you. That's so generous of you. Okay. So now max time, and then we'll do the same thing with minimum time. So boom, change this to be min, and then change this to be min, and then we'll print min time, max time. Run that. Minimum time. Okay, cool. So that looks like it works pretty darn well. So now we just need to start sliding over. So our start time will be equal to the min time, and then this is like our current. So this is for our window. So our start times min time, our end time for this specific window will be min time plus, I thought we had window. What do we call this thing? Year? Oh, we're just calling it year. Okay. I think I'll make a variable called window equals 1x year. Cool. Min time plus window. Okay. So that's our start and our end. And then now what we want to do is we want to just like iterate over, I'm trying to think of how exactly I would do this. So I guess with like a while loop. So like while end is less than max time, we want to make the query for all of the words between start and end. So c.execute, and we'll do an f string. Select word from words. Oh, it looks like we lose our syntax highlighting when we go f string on a query. That's okay. Select word from words where Unix is greater than start and Unix is less than end. Beautiful. And then we're going to say data equals c.fetchAll, and then I'm going to say break here, and then I'm going to print data. Fantastic. So now that we have that, so this is like all our individual words in that time frame. Now what we want to do is take all of these words and throw them into some sort of list, and then we'll create a counter object and then do .mostCommon10. So so before I forget, because that's the next thing we're going to do, from collections import counter, done. Okay. So data. So then we want to iterate through here and append this to words. So while this blah blah blah. Okay. We'll do words is empty to equal to an empty list, and then what we're going to say is for, well, it's not, I guess, yeah, it is row in data. So for row in data, word equals row 0, words dot append row 0. Now that's just on the fly, but we really could probably, what could we do here? We could say words equals I0, right? For I in data, right? We should be able to get away with that. So I am going to do this. I0. Oh, 4. Okay, I was like, what do you mean? Okay, cool. All right, so that works. So that gives us our words. Now we can create a counter object. So what we can say is word underscore counter equals counter words. And then what we could say is we could say common words equals word underscore counter dot most underscore common 10. And then rather than printing all of the words, we can print the common words. Why did that just happen? Because we're printing data, I guess. So let's try one more time. Yes. So we can see top of the charts, Python, not really too surprising. Bitcoin, Pi, probably with Raspberry Pi. It is kind of weird that we have more Pi than Raspberry. Not quite sure why that would be. Maybe I typoed Raspberry. That's probably it. Probably forgot the P or something. But Pi, it's fascinating. I almost kind of want to find out if that's right. I bet I just typoed Raspberry. But anyway, cool. Linux, S&P for the S&P 500. Again, probably because I don't... sometimes I type SP 500, sometimes S&P 500, but 500 always is the case. Matplotlib, I don't know what's happening here with Google. That would be an interesting one. And then Satan himself. So, okay. So that's our most common. Now we'd want to graph those. So that would be on a single time. So we're going to make a bar graph here. And we need a couple of things when we make a bar graph. I wish bar graphs were easier in Matplotlib, which, by the way, let's go ahead and import before I forget from, let's see. So import matplotlib.pyplot as plt from matplotlib. Import style and style.use. Ggplot. Okay, great. Beautiful. Couldn't ask for a better set of imports there. So now, we need to kind of set up how we're going to do this. So common words, blah, blah, blah. Okay, common words is good. We don't need to print commoners anymore. And instead what we want to say is we're going to set up the Y position. So Y pose equals mp.range. I don't think I have a numpy. Len common words. So it'll probably be 10, but later we might add that to be like a constant that we change over time. Let me import numpy, or have I? I have not. Import numpy as np. Back to work. Y position. Great. And then we're going to say word underscore counts is equal to... So actually what we need to say... Word counter. Dang it. Common words. Instead what I'm going to say is topic 0 for topic in this. Cool. So that'll be common words, and then the word counts will just kind of be the topic 1. So this will be the actual word itself in the counter, because the counter object was a list of tuples, where the first object in the tuple is the word, and then the second one was the count. So cool. Okay, so now that we have that, we're ready to actually graph this, and because we're going to save it, we want to adjust the size right away. So we're going to say plt.figure, and we're going to say fig size is equal to 12 and 7. So that should give us a 1200 by 700 pixel graph. So that's our plt.figure. Then we're going to plt.bar y pause word counts and align underscore, or I'm sorry, not align underscore, align center, and then we're going to give it an alpha of not a tuple, 0.5, just to make it semi-transparent. It'll be beautiful. And then plt.xticks y pose common words, so that way the xticks, rather than being like numbers, are instead the actual word, because that's actually what we're trying to graph here is the words, and then how much, like the y-axis will be volume. So with that said, plt.ylabel, we'll call this volume. And then finally, we'll also do a title, and we'll display the date in the title. So on a single frame, it'll be somewhat legible, but mostly what we want to do is make it somewhat readable while the frames are going at like 30 or 60 frames a second. So what I'm going to do is make this an F string. And I think we're going to bring in yet another import. From DateTime, import DateTime, and then we'll create a... I'm trying to decide what I want to do there. This is probably the dumbest way to do it. No, well, it's not the dumbest way, but I'm sure someone's going to come up with a better way, but whatever. So what I'm going to say here is we're going to do day, month, year, because that'll be the easiest to follow, I think. So just understand that's what's happening. All non-Americans are probably very happy. From timestamp. So we're going to get this DateTime object from a timestamp, meaning Unix time, and we'll go with end, because that's like, it's like the last years of data for today. Okay, so macro info up to today. So we're going to use the ending timestamp. So this, and then what we can say is dot day, month, year. Dot day. There we go. And that gives us our DateTime objects. That'll give us the day, like the number of the month, and then we'll do month dash year. So day, month, and then year. So April 1st, 2019 would be 1/4/2019, and then as these things are changing really quick, we can kind of see it, or at least know where we are along the line. So okay, so we set the title, and then now we'll just quickly run a p.2.show. Later we're gonna save the figure rather than show it, but okay. And then I guess that's it. So let's see, looks good to me. Let's go ahead and run this bad boy. That took a long time. Okay, but here it is. Hopefully it won't always take that long. Okay, so here's our graph. So the 14th of June 2014. So we can see here, nice, pretty graph. Now, it would be very tedious to go over this one at a freaking time. So instead, what we want to do is make it into a video. So the way we're going to do that is first we have to save all the images. So I'll probably save all the images and kind of like pause while I do that, and then we'll pick back up. So I'm gonna clear this out of the way, and rather than plt.show, we're gonna plt.save underscore fit, no underscore, save fig, and again to an f string, and it's gonna be savedr, right? Is it gonna be savedr? Yeah, because that's where we want the images to go. And then we're going to make the video from the save. So we'll put both into the savedr. So savedr, and then we want to save the images with like a counter. So we're going to start a counter equals 1. Or actually, let's start at 0, so a range is easier. Counter 0, and then every time this is successful, we're going to tick up the counter. Wow, and blah, 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 save fig. So yeah, and then we'll do counter dot png, no longer show, because that'll take forever. And then when all that is done, it's counter plus equals 1, and then we would do start plus equals the window. No, plus equals slide, right? Because we want to slide it by a day. And then end plus equals slide. Woo, that was rough. Okay. Yes, I think we're good. Very good. Let me come down into here, gdata, and let's go ahead and run images.py. Python images.py. And let's see how that goes. I wonder if we're printing stuff we probably don't want to print. We also don't know where we are along the way. Let me go ahead and print counter. I'm going to save that. I don't really know if I want to change it. Let's just check the images real quick and just see if they're saving. Open! Wow, everything's going really slow on this machine. Why won't you just open an image, bro? I have no idea. Why can't I open this image? There we go. Thanks, idiot. Okay. Cool. Yeah, so that looks good. I'm just kind of shifting through the images. So now what we want to do is make a video out of those images. So we'll just kind of let this run while we work on image video. So I'm going to go back to gdata, and I'm going to take images. I'm just going to copy and paste just to have a PY file, basically. Image video. So now what we're going to do is convert images to video. And I've already got code that does this, so I'm just going to go copy and paste it. So I'm going to go to the best Python learning website in existence. I'm going to go type in unconv. Yes, sir. There it is. And I'm going to go to unconventional neural networks. And then I'm going to go down to Deep Dream. Deep Dream. Frames. Deep Dream video is what I'm after. Thanks. And now I'm going to just copy and pasta all this jazz, and then we'll change what is necessary in a moment. Just take note, though, I do have two different. If you're on Windows, use this. If you're on Linux, use this. If you're on Mac, I actually don't know. Out. We do need to modify out to be the proper resolution. This, I'm just going to probably hard code, so I'm going to skip that. That's just trying to find the length of the dream, really. Out.release done. If you haven't watched that video, by the way, check it out. A deep dream of a neural network. Those are actually really cool. It's just like every frame, it runs a neural network that kind of like applies the patterns it sees basically to an image. It's super cool. Definitely, you just have to go see it. Okay, so let's see how we're doing. Still going. Still making the images. Good to know. Good to know. Okay, so great. So now all we're going to do is start modifying this stuff. So I don't need dream name. Fudge. What? Failed to allocate. Okay, that's going to be a problem because this takes a while. I really don't want to start that over again, and I also don't know what that issue is. So we should probably end up making about, 356 times, and it was like 5 years. Well, a little less than 5 years. So more than 356, that'd be more than 1,500. So about probably like 1,800 images. So let's go properties. Dang, we're way off the mark. And if we have to keep doing this every like few times. So here's what I'm going to do. I'm going to just hack it, and I'm going to say import OS, and then we're going to check to see if this image exists. So we're going to say if os.path.isFile, and then we're going to check with an f string for this. Like if this image has already been saved, then forget about it. Let's just move on. Boom. What is wrong with you? Pass. Else, then we need to create that image. So we'll do all of this up to the counter, tabbed over. Boom, boom. Okay. Slide. Save. And let's continue running. Python images.py. Great. Picked up where we left off. Perfect. We'll probably have to do that like 5 more times, but hey, it's in the name of science, everybody. So here, let's just say for I in range for now 300. It's just however many images we have, so that's no big deal. Image path is going to be basically this path where the images are, right? So we're going to just copy pasta that into os.path.join. Now, this for I. This will just be I.png. That's correct. Good stuff. Good stuff. Saved her. We probably don't have that actually. Let's grab that real quick. Where is it? Here it is. That's kind of gross. I don't know if I want to, because I'm going to change this. That's going to be annoying. That's okay though. Let's just go. Weird, I thought I deleted these already. Anyway, saved her, boom, done. Out, format. Again, that'll be this, dot, and rather than, I'll fix that. So format, so this, saved her / video dot AVI, and then it needs to be, we're going to go with 60 frames a second, a little quicker. 30 frames will take a while, and we just kind of want to see it over time. So then it'll be 1200 by 700. Save that. And let's just see how many words we have now. Or images, rather. 607. So we'll just say 600. We will save that. And while we're waiting for that other thing to run, let me just do this. Python image video.py. That'll create the video, hopefully. Let's see what happens. It looks like it's doing it, so that's cool. And it'll go in here, and it'll save to here when it's done. Awesome. And let's see what it looks like so far. I don't care. Yeah, this is cool. So I wish video.avi would go away. So yeah, so here you can actually see as like certain things like tick up and then go away. So Python pandas, you got Bootstrap, Flask, and then we cut out. But anyways, it's kind of cool because you can like see all this stuff changing over time. 2007. Okay, we lost Python. No problem. We've got some epic error handling over here. Failed to allow. I wonder if anybody knows what's going on. I don't think, like, I'm not sure if we just ran like a clear fig, if that would help. Like, I'm just not sure. Failed to allocate bitmap. Failed to allocate bitmap. Matplotlib. plt.close fig, but we don't have a fig. We'd have to, I guess, create a figure or maybe redefine a figure. I don't know. By the time I debug that, we'll be done. So I just don't really feel like doing it. So now I'm just going to keep doing this until we get to like we're done with our, probably 1800-ish, maybe more, maybe less. Okay, and then when we're done, I'll show you the video, and then I'll probably just leave it. Maybe I'll do another one. I just don't really see much point. It's more interesting looking, like I'm interested in seeing my data, and I'm sure some people are interested in seeing my data, but too bad, do it with your own data. So while we wait, shout out to some of my channel members who have been long-term channel members with me for 6 and 7 months. Joseph Coleman, Bill Follensby, Luis Fernando, I'm gonna mess that up. Reginald Roberts and Metanoia. Guys, thank you so much for your long-term support. You guys are freaking amazing. I wish YouTube gave me better options for like figuring out when people have re-upped, and even like some of the other. I'm trying to think what the. I'm just like blanking on the name right now, but there's like stream options like people use for streaming, and like that whenever someone re-ups it should be listed right, but I feel like the YouTube API is like not helping people figure out when someone has like re-upped. So anyways, I just have to like manually go through that list, and that's kind of weird. Okay, so I'm gonna pause here and then I'll come back when this stuff is done and we can kind of see at least my macro search. Don't think I'm going to do the micro stuff, but if you wanted to, you really would. You would just go over here, change the window. So this is just going to be really big stuff that I did like lots of searches of, and then it's going to dominate the stuff that I did, on a micro level. And then, if you go down to the month, you'll get just much more granular stuff going on. So definitely really interesting. I encourage you to check it out with your own data. Anyway, I'll come back when this is done. All right, and we are done. I went ahead and converted to video, and we can watch in all its glory. So looks like Python tops the charts, but then you can kind of see like you got Pandas, Flask, whatever Google's doing there. You can also see Elite Dangerous, like Elite and then Dangerous, which is a video game, and it's kind of interesting to see how that kind of goes up pretty high. Well, I think it made it maybe temporarily to like 4th and 5th spot, and then that goes away. You got 76126. That's zip code. Pokemon comes up, probably for Pokemon Go. I'm surprised we don't see Go here, but whatever. Then you got the S2000 pops in, climbs like almost top in the chart. Really battling Python there. It definitely, oh, it shoots up. And it definitely passes Python and OSRS, old school RuneScape. Shouts out. Texas, TensorFlow, Car, and Grand Theft Auto towards the end of 2017. S2000 starts falling off, which is pretty true. I eventually moved away, and I still have the S2000, but I just don't really drive it very much anymore. Then pops up 35404, not yet passing 76126. It's probably going to take a while. Like, because we're going back on an entire year when I actually moved, is probably going to take a pretty significant time to surpass the other one. Like, probably about 6 months would be mathematically it, and looking at that's curious. Anyways, but yeah, there's 35404 now on the chart. 76126 is gone. Porsche's coming up. Old school RuneScape, top in the chart. Whoops. I don't know why that happened. And then we finish April 4th, 2019. Old school RuneScape, killing it. It's because I'm a Python expert. I don't have to Google Python anymore. And 35404 zip code, Porsche, weather, no surprise. Keros, I'm surprised Keros is that high in the charts, to be honest with you. Alabama, Tuscaloosa, guess where I live. Pandas. All right. Well, very interesting. Okay, well, hopefully your data is interesting as well. I strongly recommend you change some of the windows and then kind of like look and see how your trends change over time. We could totally easily create an algorithm that as something like you would just compare the previous top 10 to the new top 10, and anything that's changed, like as one comes out, like any change means one left and one came in, or more. Could be 2 or 3. But it would be cool to track that over time, so you know exactly when those changes occurred, and you could probably get a pretty, like I said, because it's a year, like any major event, like when I moved or something like that, any major event would definitely take a decent period of time to actually shift over. So, but I just wonder what would happen if we went down to like a week or a month. It would be almost perfect, like to figure out when major events changed, or like when I bought a new car and like all that stuff. So anyway, pretty interesting, and using pretty rudimentary programming, I think we can find out a lot about people. So anyways, cool. If you guys want to see more about playing with Google data, let me know down below what you'd like to see and all that. Definitely want to do text-to-speech with our own voice. I think that'll just be really cool. So kind of hoping to do that, but we'll see about that. Anyway, if you got any other ideas, feel free to leave them below. As always, thanks for watching. Thanks for all the support, the subscriptions, the memberships, the donations, all the fun stuff. And I will see you guys in another video.